There is a job in Japan that involves standing on the flank of an active volcano with an instrument pointed at the sky, reading sunlight. That is how you weigh a volcanic plume. You do not fly through it. You do not scoop it into a jar. You aim a spectrometer at the light coming down through the gas. You measure how much of that light the sulfur dioxide has swallowed, and from the missing light you calculate the mass. It is one of the strangest measurements in all of Earth science. And on the afternoon of the 14th of August, a field survey crew from the Japan Meteorological Agency did exactly that on the slopes of Nakadake, the restless heart of Mount Aso. The number they came back with was 2,700 tons per day. 45 minutes later, Japan closed the mountain. That is the headline, and it is a real one. But it is not the part that has kept me reading these bulletins for the last 10 days. Because the gas number is loud, and the thing that should hold your attention is silent. It started 3 months before any of this made the news. It is not happening at the crater. It is happening under a grass meadow where families spread out picnic blankets and children ride horses, and the only reason anyone knows about it at all is that a few satellite receivers have been slowly, patiently disagreeing with each other about how far apart they are. Follow the numbers in order because they build in a sequence, and by the end of this you will understand what Japanese volcanologists are watching better than most of the news coverage explained it. If you want the rest of this story as the readings come in, the subscribe button is how you get it. So, the sequence. On the 28th of July, a survey at Aso measured 700 tons of sulfur dioxide leaving the crater every day. That is a normal to elevated reading for this volcano. 9 days later, on the 6th of August, the number was 1,200 tons per day. Elevated, but nothing that would empty a mountain of hikers. Then came the 14th, and the number nearly doubled again to 2,700. Let me make that real, because tons per day is an abstraction, and this is not an abstract thing. 2,700 tons in 24 hours works out to about 112 tons every hour. That is close to 2 tons a minute. Every minute, a grand piano's worth of invisible, corrosive gas boiling out of a hole in the ground 4 times a minute without pause, day and night, while you sleep, while you work, while you watch this. It does not stop for weather. It does not stop at night. And unlike ash, you cannot see it. Sulfur dioxide is colorless. The white plume you see rising over Nakadake in the webcam feeds is mostly water vapor. The dangerous part is riding along inside it, invisible. Why does that number matter so much to a volcanologist? Because sulfur dioxide is not a surface phenomenon. It is a messenger from below. Sulfur stays dissolved in magma under pressure, the way carbon dioxide stays dissolved in an unopened bottle of soda. When magma sits deep, the pressure holds the gas inside the melt. As magma rises, the pressure drops and the sulfur comes out of solution and escapes upward through cracks. So a sudden, sustained jump in sulfur dioxide output is not the volcano being noisy. It is the volcano telling you that fresh, gas-rich magma has moved closer to the surface than it was last week. You are not measuring smoke, you are measuring depth. And to know whether 2,700 is a lot, you need to know what quiet looks like at this particular crater. Nakadake has 7 craters, but only the northernmost one, the first crater, has done anything at all in the past 80 years. During calm periods, that crater holds a lake, not a pretty alpine lake. A hot, milky, jade-green pool sitting at somewhere between 40 and 80 degrees Celsius with a pH below 1. That is roughly the acidity of concentrated hydrochloric acid. It is one of the most acidic natural bodies of water anywhere on this planet, and it exists because volcanic fluid is being fed into it continuously from below. The lake is not rainwater. The lake is the volcano's exhaust, condensed. When that crater is behaving, sulfur dioxide output measured at Aso typically runs somewhere in the range of 200 to 400 tons per day. Now go back and look at the 14th of August again, 2,700. That is not double the calm rate. It is something on the order of 7 to 13 times the calm rate. When you hear a Japanese agency describe a gas reading as sharply increased, that restraint is doing a lot of quiet work. And there is a second thing the lake does. It is a gauge. Through Aso's active cycles, the sequence has repeated. The lake heats, the level drops, the water boils away, the exposed mud on the crater floor glows and dries and cracks, and when a vent opens in the dried floor, eruptions become possible. That is the ladder this volcano climbs. Which is why one detail in the bulletins from the last 2 weeks matters more than it looks. Webcam observation has reported no significant change in conditions inside the crater itself. The gas surged. The tremor surged. The floor of the crater, so far, has not. That is one instrument. There was a second, and the second one is what actually triggered the decision. At around 7 in the evening on the 12th of August, the amplitude of volcanic tremor at Aso started climbing. It wobbled for a couple of days, rising and falling. Then, just after 3 in the afternoon on the 14th, the north-south component at the Nakadake West Flank monitoring station pushed past 4 micrometers per second and stayed there. 4 micrometers per second sounds like nothing. It is nothing in the sense that you could stand on that ground and feel absolutely no motion whatsoever. A human hair is about 70 micrometers thick, so the ground was shifting back and forth by a distance roughly 1/17 the width of a single hair every second. You could not feel it with your feet. You could not see it in a glass of water. Only a seismometer bolted into rock could tell you it was happening at all. But here's the comparison that gives it teeth. During calm stretches at Aso, that same station typically reads somewhere around 1 to 1.2 micrometers per second. So 4 is not a small increase. It is roughly 4 times the quiet baseline, sustained, not a single spike. And there is a deeper reason tremor matters more than the raw size suggests. Volcanic tremor is not an earthquake. An earthquake is rock breaking. It is sharp, it starts, it stops, it has a beginning and an end you can point to on a chart. Tremor is different. Tremor is continuous. It hums. It goes on for hours or days without a clean start or a clean finish. And the reason it hums is that it is not caused by rock snapping. It is caused by fluid moving. Gas and magma forcing their way through narrow conduits, making the surrounding rock resonate the way air makes an organ pipe sing. So when a seismometer at Aso stops recording occasional sharp cracks and starts recording a sustained hum instead, the message is not that the mountain shook. The message is that something is flowing through it. 2 independent instruments, measuring 2 completely different physical things, both saying the same sentence at the same time. That is why nobody waited. At 3:45 in the afternoon on the 14th of August, the Fukuoka regional headquarters of the Japan Meteorological Agency raised the volcanic alert level at Aso from 2 to 3. Now, what does that mean? Because this is where a lot of coverage went wrong, and this is where you need to be more precise than the internet was. Japan runs a 5-step volcanic alert scale. Level 1 means the volcano exists, and you should remember that. Level 2 restricts the area immediately around the crater. Level 3 restricts entry to the mountain itself. Level 4 is a warning for elderly and vulnerable residents to evacuate. Level 5 is a full evacuation order for inhabited areas. Aso went to 3. That is a serious step, and it is not a small one. It shut the summit. Climbing Takadake, Nakadake, Kishimadake, and Eboshidake is now prohibited. The crater viewing area, one of the most visited volcanic sites anywhere in the country, is closed. The agency warned of large ballistic blocks, rocks measuring roughly 20 to 30 centimeters, thrown on ballistic arcs, and of pyroclastic flows reaching areas within about 2 kilometers of the Nakadake first crater. 3 municipalities were named in the warning zone: Aso City, the town of Takamori, and the village of Aso. 2 kilometers is about a mile and a quarter, 25 minutes of walking. Close enough that if you were standing at the old viewing platform when something happened, distance would not save you. And a rock the size of a bowling ball arriving from above at highway speed does not care how healthy you are. But level 3 is not evacuation. Nobody in Aso City has been told to leave their home. The road up to Kusasenri, the famous grass plain inside the caldera, is still open to traffic. Restaurants are serving, hotels are booking. Life inside the caldera, where tens of thousands of people live and work on the floor of a volcano, is continuing more or less normally, because that is what Japanese volcanic risk management is designed to allow. A hard, narrow exclusion zone around the vent, and ordinary life everywhere else. If you have seen a video in the last 2 weeks telling you Japan is evacuating around Mount Aso, that video is wrong. It was not evacuating. It closed a hiking trail and a tourist overlook, which brings up a question worth pausing on because the geography here is genuinely difficult to picture. What exactly is Mount Aso? Most people picture a cone, a volcano-shaped volcano. That is wrong, and the wrongness is the whole point. The Aso caldera is about 24 kilometers across, 15 miles. You can drive from one wall to the other in under 20 minutes at highway speed and spend that entire drive inside the volcano without once feeling like you are in one, because the floor of it is farmland and towns and a railway line and rice paddies and roads. It is not a mountain with a hole in the top, it is a bowl in the earth with a civilization living in the bottom of it. Rising from that floor is a cluster of 17 central cones, built up inside the bowl long after the bowl itself was formed. One of them is Nakadake. Nakadake is one of the most active volcanoes in all of Japan, and it holds a distinction almost nowhere else on Earth can match. The eruption recorded there in the year 553 is the first documented volcanic eruption in Japanese history. Nearly 15 centuries of written record, 187 eruptions cataloged across roughly 10,000 years, an eruption in nearly every century since the 6th. Its most recent confirmed eruption was in October of 2021, when it threw an ash column 3.5 kilometers into the sky. That is around 11,000 feet, higher than most commercial aircraft cruise on a short domestic hop. So this is not a sleeping mountain waking up after a long silence. This is one of the busiest volcanoes on the planet doing something it has done in some form over and over for as long as anyone in Japan has been writing things down. Here is a question I would like you to answer in the comments, because the responses on this one are always the best part. Have you ever stood on an active volcano? Not seen one from a plane window, actually stood on the ground of one. Aso, Etna, Kilauea, Vesuvius, anywhere. Tell me where, and tell me whether you thought about what was underneath you at the time. I read those. Now the part that took over the internet and the part that needs correcting, because it is the single most repeated claim about this event and it does not survive contact with the timeline. On the 28th of July, at 27 minutes past 4 in the afternoon, a magnitude 7.1 earthquake struck Kumamoto Prefecture. The United States Geological Survey put it at 6.8. It registered the maximum value on Japan's seismic intensity scale in the city of Uki and the town of Hikawa. At least 39 people were killed, more than 350 were injured, around 300,000 people were told to seek shelter. Part of a shopping mall came down with people inside it. That earthquake happened 17 days before Aso's alert level went up, and the internet did what the internet does. The quake shook the magma, the quake cracked the plumbing, the quake woke the volcano. The Japan Meteorological Agency was asked this directly at a press conference, and the answer was unambiguous. There is no clear data showing that the earthquake led to an increase in volcanic activity. The agency added something else that most of the viral posts left out. Activity at Aso had already been intensifying before the earthquake struck, and the record backs that up cleanly. In the middle of June, sulfur dioxide at Aso measured around 900 tons per day. Days later, it had risen to about 1,700, alongside a burst of tremor, and the alert level was lifted to 2. That is more than a month before the ground moved in Kumamoto. The escalation was already running. I want to be careful and fair here, because there is a real scientific question buried under the bad version of this story. Large earthquakes can, in some documented cases, influence volcanic systems. It is a genuine field of study. But possible in principle and happened here are two very different sentences. And the agency responsible for monitoring this volcano with the actual instruments looked at the actual data and said there is no clear signal of it. The volcano was already climbing before the quake. Blaming the earthquake makes a better story. It just does not match the readings. Now, let me give the other side its strongest possible version, because it deserves one and because almost nobody making videos about this has bothered. In April of 2016, a devastating earthquake sequence struck Kumamoto Prefecture and killed hundreds of people. 6 months later, on the 8th of October that year, Nakadake produced the largest eruption it had managed in decades. Anyone who lines those two events up and feels a chill is not being stupid. They are noticing a pattern. And the honest scientific answer is that the relationship between large earthquakes and nearby volcanic systems remains an open, actively debated research question, not a closed one. But notice what that argument requires. It requires a 6-month gap to count as a connection. Stretch a rule like that in the other direction, and almost any earthquake anywhere becomes the cause of almost any eruption anywhere. Meanwhile, the specific claim on offer right now is a 17-day link to a volcano whose gas output had already doubled, whose tremor had already spiked, and whose ground was already inflating before the earthquake happened. The people with the instruments looked and said no clear data. That is the answer until better data arrives. And if better data ever does arrive, I will come back and say so. And since we are at that eruption, it is worth knowing what Nakadake is capable of, because the modern record here is not theoretical. At 52 minutes past 9 on the night of the 7th of October 2016, a small eruption began. 4 hours later, at 46 minutes past 1 in the morning, the mountain did something far larger. Seismic records suggest the main explosion lasted somewhere between 160 and 220 seconds, under 4 minutes. In that time, it pushed an ash column to around 11 kilometers, close to 36,000 feet. That is passenger jet altitude. Ash fell across Kumamoto and Oita, and then kept going, over the sea, onto Ehime, Kagawa, and Okayama. Ash was reported at distances of up to 320 kilometers from the crater, which is 200 miles, roughly the distance from London to Newcastle. 3 centimeters of ash piled up at the Aso City Police Station 6 kilometers away. Farmers 6 to 8 kilometers out found the vinyl on their tomato and asparagus greenhouses punched through. A window cracked at a youth center 5 kilometers from the vent. Read that list again and notice what it does to the 2-kilometer exclusion zone. That zone is not a promise that nothing crosses it. It is drawn for the hazards that kill instantly and locally, the ballistic blocks and the pyroclastic flows. Ash and small stones ride the wind, and the wind does not respect circles on a map. Which is also why there are concrete shelters built along the paths near the crater, squat and ugly and entirely serious, put there for people who might have seconds rather than minutes. Which finally brings us to the thing I promised at the start, the quiet one, the one under the meadow. Kusasenri is a wide, green plain inside the Aso caldera. Grass, a shallow pond, horses for tourists to ride, one of the most photographed landscapes in Kyushu. It looks like the least threatening place in Japan. Underneath it, deep down, is a magma reservoir. You cannot see it. You cannot drill to it. What you can do is watch the ground above it with continuous satellite positioning receivers, the same technology in your phone, but refined to a precision that borders on absurd. Plant 2 receivers on opposite sides of Kusasenri, measure the straight line distance between them constantly for years, and you can detect that distance changing by a few millimeters. And since about May of 2026, the baselines spanning Kusasenri have been lengthening. Not just the local ones, the wide area baselines too. The ground is stretching. Picture an air mattress on a floor with a person standing at each end. Start slowly inflating it, and the two people drift apart. Neither of them feels the ground move. Neither of them would ever notice. But measure the distance between their feet with enough precision and the inflation becomes undeniable, even though nothing visible has changed at all. That is Kusasenri. The receivers are drifting apart because something below is filling. And that is the reading that reframes everything else in this story. Because gas output can spike and fall back inside a week, tremor can rise and settle in an afternoon. Those are surface symptoms, and surface symptoms come and go. Ground deformation driven by magma accumulation is not a symptom. It is the supply. It is the volcano being fed. And it started in May, ran quietly through June and July while nobody outside the agency was paying attention, ran straight through the earthquake, and was still being reported in the bulletins issued this week. The gas spike was the alarm. The inflation is the cause. Now, I need to draw a hard line here, because this is exactly the point where a lot of channels drive off a cliff, and I am not going to. Search Mount Aso online and you will find the word supervolcano within about 4 seconds. And it is technically defensible in a way that is completely useless to you. The Aso caldera was formed by 4 enormous explosive eruptions between roughly 300,000 and 90,000 years ago. The last of them, called Aso 4, produced more than 600 cubic kilometers of ash and pyroclastic material. Flows from it covered a large part of Kyushu. 600 cubic kilometers is a number the human brain refuses to hold, so here it is a different way. Spread that material evenly across Greater London, and it would bury the entire city under more than 1,200 feet of ash. Not the buildings, the city. Skyscrapers, cathedrals, the river, all of it gone under a layer deeper than the tallest structure standing there today. That happened. It is why the caldera exists. It has nothing whatsoever to do with what is being measured right now. The magma reservoir under Kusasenri is the ordinary plumbing that feeds Nakadake's ordinary eruptions, the small to moderate ash events that have punctuated Japanese history for 1,500 years. Caldera-forming eruptions require the accumulation of enormous volumes of eruptible, gas-charged magma over timescales measured in tens of thousands of years, and they announce themselves with signals of a completely different character and scale than a few millimeters of extension across a meadow. No official source has said Aso is heading toward a caldera eruption. Not the Japan Meteorological Agency, not the Fukuoka Regional Headquarters, not the researchers who monitor this system daily. The scenario in the actual warning is explicit and limited, an eruption capable of affecting areas within about 2 kilometers of the crater. Blocks, pyroclastic flows on a local scale, ashfall downwind, volcanic gas. That is worth taking seriously. Ash closes airports and grounds aircraft. Blocks kill people who ignore exclusion zones. Volcanic gas is lethal to anyone with respiratory or cardiac vulnerability. And at Aso, the gas hazard is severe enough that the crater has its own separate gas-based restriction system, independent of the eruption alert level entirely. The honest version of this story is a serious, well-monitored, escalating volcanic situation at one of Japan's most active vents. The dishonest version is a doomsday cartoon. The honest one is more than alarming enough. It also has the advantage of being true, which raises the obvious question. Nearly 2 weeks have passed. What has the volcano done since? It has calmed down partly. Through the period from the 19th to the 24th of August, tremor amplitude at Aso has been running mostly small, rising and falling, but nothing like the sustained 4 micrometers per second that triggered the upgrade. The gas has come down too. On the 19th, sulfur dioxide measured 1,200 tons per day. On the 21st, 1,100. Still classed as somewhat elevated, but a long way below 2,700. The white plume above the first crater has been reaching as high as 1,100 meters above the rim. That is around 3,600 feet of visible column standing over the mountain, more than 3 times the height of the Eiffel Tower, and webcam observation has shown no significant change in conditions inside the crater itself. No new vent, no ash emission, no eruption, and the alert level has not been lowered. It is still at 3. That decision tells you something. If this were only a gas and tremor episode that had passed, the level would come down, the way it has come down at Aso many times before. It has not come down, and the bulletins keep repeating the same sentence about the satellite data. Continuous observation since around May of 2026 shows extension across the baseline spanning Kusasenri and across the wide area network, suggesting the accumulation of magma in the reservoir believed to lie deep beneath it. The surface has gone quiet, the supply has not. So here is what to watch, and these are specific. Watch the sulfur dioxide figure in each new field survey. If it climbs back toward 2000 or beyond, fresh magma is moving up again, and the 14th of August was a first pulse rather than a peak. If it settles down into the hundreds, this particular episode is winding down. Watch the tremor amplitude at the Nakadake West Flank Station. Past 4 micrometers per second, sustained, is the number that already moved the alert level once. Watch the Kusasenri baselines. If the extension stops, the feeding has stopped. If it keeps going, everything at the surface is downstream of it, and the next episode is only a matter of when. And watch the crater webcams for a change in plume color. White is water, gray is rock. The moment that plume turns gray, the volcano is no longer only breathing. Japan will keep publishing all of it on a schedule, in public, whether it makes headlines or not. The next bulletins are already scheduled, somewhere under a green field where tourists photograph horses against the caldera wall. The ground is still a few millimeters wider than it was in the spring. Subscribe and turn on the bell, and when those numbers move, you will hear it here before it turns into a headline.